Hello everyone, today in this video we'll be discussing the module 4 of DSA super important questions, and if you watch this video till the end it is more than enough for you to score more than 80% marks. And don't miss any of these questions. These are the most repeated ones and taken from the previous year papers and the model question paper. And before starting, please do like and subscribe. It helps me make more videos like this. So without wasting more time, let's get started. Design an algorithm to traverse a graph using DFS depth first search and BFS breadth first search. Okay, and apply the DFS and or BFS for the given graph below. Okay, so either DFS will be asked or BFS will be asked, or they can ask both of them just with the algorithm. Okay, so I'll be discussing all of them together. So here this is the graph given to us, and we have to find out, first we have to write an algorithm. Okay, first we will discuss the algorithm for both, and then we will see how do you apply the DFS and BFS for solving this question. This is the 8 mark question. Okay, now for the algorithm part, what you have to do is you have to write void BFS, and you have to take a graph star graph, and in start vertex the starting vertex. Okay, and you will be declaring three things. Q max, it is an array where all the nodes will be stored, and we use Q for BFS. Okay, and stack for DFS, and two pointers will be used, front and rear. Okay, firstly we will be initializing the graph of visited of start vertex as 1, so that we keep track of what all is visited. Okay, for that visited is used. And q rear plus plus is equal to start vertex, means we will be assigning the means we are assigning inside the queue the start vertex. Okay, means whatever the traversals we are doing, whichever nodes we visit, that we will be assigning it to the queue. Okay, and where we'll be assigning, in the rear place, and rear will be updated so that next whatever node we traverse, it will be stored in the next position. Okay, and then a while loop is there, and that's all. Okay, so in the while loop, while front is less than rear, front will always be behind rear. When front will cross rear, that means that there is no more elements. Okay, all has been visited. So we'll take a current vertex from the queue, and we'll be printing it as visited. And after that we'll be taking a temporary pointer from the adjacency list of current vertex. What does adjacency list contain? Adjacency list contain all the neighbors. Okay, so if I ask you what is the neighbor of B, neighbor of B is F, D and A. Okay, like that all the neighbors will be taken in temp, and one by one we will be considering all the neighbors, and we will be visiting them. Okay, so temp consists of all the neighbors, and we will be taking the first neighbor and putting it in adjacency vertex, and we will be visiting that if it is not visited, and we'll be making it as 1. After that we will be making the queue of rear plus plus as adjacent vertex, because whatever we visit we will be having to put inside the queue. And once this part is done, we will be moving to the next one. Okay, like that we'll keep on going until all the vertices are visited. Okay, so this is the BFS algorithm. Next is DFS algorithm. In DFS algorithm, what we do is, here also we'll accept a graph and the starting vertex, and whatever the starting vertex is there, we'll mark it as 1 so that it's visited, and we'll be printing that also. After that we take in temp the adjacency list of all the vertices, and while the temp is there, means unless and until all the vertices of the adjacent vertices of the vertex is not visited, we will be taking an adjacent vertex one by one. And if it's not visited, we will be calling a DFS again. What does basically DFS do is, it will go in depth. Okay, means first it will visit this, then this, then this, then this, and once it reaches the end, it will come back and visit the next neighbor, and until it reaches the end. Like that is DFS. BFS means it will first visit all the neighbors, then it will visit the neighbors of the neighbors. Okay, then it will visit the second neighbor of the neighbor. Like that will keep on going. Okay, so when we solve the question, it will be more clear for you. So this is the algorithms you need to write for DFS and BFS. Moving on for the problem solving, first we'll solve the BFS problem. Okay, and remember in BFS we will be using a queue. Okay, so queue means first in first out. Whatever the element we put in first, that will be the one which will be out first. Okay, so basically you have to make this table here. You'll be having three things: node, queue and BFS. Okay, BFS is the sequence in which the nodes are visited, that will be storing here. So take any of these nodes first. They have not given in the question explicitly which node you have to take, so you'll be taking any of these nodes. So first I will be taking F here. Okay, and whichever node you take here, the neighbors of that node you will be writing in queue. F's neighbor is B, means F is connected with whom? F is connected with B, F is connected with D, so you'll be writing B comma D. Okay, in any order you can write DB also. And whenever a node is written here, you will be writing it in BFS as well. Okay, after you have done that, from the queue you will be taking the first node which is pointed here and putting it here. Okay, so now B is being considered. Okay, now B is being considered. It is removed from the queue and taken into consideration. Okay, and since B is removed, only D is remaining here. And next step what you have to do is find out the neighbors of B. Neighbors of B is F, D and A. F is already considered here, will not consider that. D is already written here, will not again write it. The remaining one is A, so we'll be writing comma A. Okay, and whichever node you have written here, that you have to write it in BFS. So F is already present, you will be writing B also. So this is the sequence in which we are going to visit. First F is visited, then B is visited. Like that, we'll be joining the sequences, and as and how we encounter new nodes. Okay, again D is in the first position here, we'll be writing the D here. Okay, and A is remaining here, so we'll be writing A. Then next, the neighbors of D. Neighbors of D is F, B and A. All are not valid because all are already taken into consideration. So we'll not do anything, we'll just write the D after the initial sequence here. So D will be written here. Okay, next A is present here, so take A here and find out the neighbors of A. Neighbors of A is C and E, so we'll be writing C comma E. And after that, you'll be concatenating A with the existing BFS sequence. Okay, after that you'll be taking C here and you'll be finding out the neighbors of C. What are the neighbors of C? A and G. A is already considered, G is not considered, so we'll write as G here. And since C we have taken here, it will be added to the existing sequence of BFS, so C will be added here. After that, E will be taken into consideration and G will be here. So the neighbors of G are C and E. Both are not valid, so we'll not do anything, we'll just keep it as such. Since E is taken into the node, we have to add E to the existing sequence of BFS, so we'll be adding an E at the end here. And finally, G is present here, we'll be taking G, and there are no more neighbors of G which are to be considered. It is empty in the queue, so we will be just writing again the same sequence here. F, B, D, A, C, E and G will be written here. So the BFS, final sequence of BFS you have to write in the exam is F, B, D, A, C, E and G. Okay, this is the answer you need to write, and with this answer you need to write this diagram, means the table, so that the examiner will know this is the way you calculated it. Okay, if you just write the answer, you will lose marks. So don't make that stupidity, you just have to follow these steps and make this table, and then only write the final answer. Okay, moving on to the next one, which is DFS. Okay, in DFS it is a depth first search. Okay, here we will be using stack. Okay, so any node you can start again. We'll be taking F here. So in the stack you'll write the neighbors of F. The neighbors of F are B and D, so you'll be writing B and D here. Okay, and DFS, whatever you encounter, you will be writing it here. Okay, F. Next, after that, you'll have to take the neighbors of this one. Okay, and this is a stack. Okay, stack means last in first out. Last in means after B, D came. So which came last? D came last, right? So you'll be taking D here and you'll be writing the neighbors of D. Okay, B will be as such, you will be writing the neighbors of D. Neighbors of D are F, B and A. F and B are invalid, so we'll be taking A here. Okay, F and B already considered, so we'll not take again. And we had the third neighbor is A, so we'll be writing A here. And whatever we visited, we'll be writing it in DFS also. After that, the last one is A. We'll be taking A into consideration, and A is connected with B, D, A, B, D, C, and E. Right, four things it's connected to, but B and D are invalid because we already considered it. So we'll just take C and E. Okay, so we'll be writing here C comma E. Next, F, D and A we have to write it here. Then we'll take the last one, which is E. Okay, last in first out. So B and C will be remaining, and the E's neighbors are whom? E's neighbors are A and G. A and G, A is invalid, we'll be writing G here. Okay, after that we'll be writing the E at the end of the existing sequence of DFS. Next, after that we have to take the last one, G, and the B and C will be remaining. The G's neighbors, everything is considered, so we'll not do anything. We'll just write F, D, A, E and G. After that we'll be taking the last one, C, and nothing is remaining in C as well, all the neighbors are considered, so we'll be writing the sequence F, D, A, E and G. After that we'll be writing C, and the last one we'll be writing here as B, and the sequence will be the final sequence F, D, A, E, G and C. After that finally B. So in the exam also you'll have to write the same thing. The DFS final sequence will be F, D, A, E, G, C and B. Okay, so don't forget to make this diagram, otherwise you will use marks. Okay, so this is about the DFS and BFS. Every question you have to solve in the same way. Okay, just remember, in stack, in DFS we have stack, and in BFS we have queue. Okay, moving on to the next super important question from the module 4 of DSA is construct a binary tree from the post order and in order sequence are given below. Okay, so this is for 8 marks, and all you have to do is follow the few steps which I will be telling you now. In order is given and post order is given. Okay, so in order and post order is given, you just have to write the same thing in the answer sheet, in order and post order. Okay, after that, what is the in order's code word? In order's code word is LNR. LNR means left, node and right. Okay, and post order's code word is LRN, which is left, right, and node. Okay, now after you have done this one, listen very carefully. Okay, always they will not ask in order and post order only. They can give you in order and pre-order. You might have to make post order. That is also possible. Okay, so listen very carefully. After you have written the code words, what you have to basically do is start from the post order or pre-order. These two you have to start. Okay, and in post order, if you observe carefully, it is LRN. LRN means after left and right is over, finally n will be there, the node, whichever the node is present, that will be written at the end. So in post order, end node is the one which is the root node. Okay, always end node will be the one which is root node, because root node will be written only after the left part and right part of the root node is over, and finally we'll be writing n. If you have solved any post order question in the traversal, you'll understand this, that at the end we will be writing the root. So firstly we have to find out which is the root. Okay, so we have got the root is a here. Okay, now the root we have got a, and left and right part we are still confused. Okay, so we'll be then having a look at the in order. In order, where is a present? A is present here. A will be written only after left part is over, then a will be written, then right part will be taken into consideration, right? So n denotes the segregation between the left and the right. So a's left part is the left tree and a's right part is the right tree. So a's left part I will be writing it as GDHB, and a's right part I will be writing the remaining one EICF in the same order. Okay, EICF. Now A is sorted. Next we have to apply the same logic for GDHB and EICF as well. Okay, so for GDHB you have to look first in the post order. In post order, where does GDHB lie? GDHB, it lies in the different order, but it lies here in the starting part here, and at the end we have B, right? If we consider GDHB, at the end we have B here. So if B is at the end, B is the root node. Okay, for this particular sequence, B is the root node. That much we have got. Now if B is the root node here, here what we consider L and R, right? So B's left part is L and B's right part is R, but B's right part there is nothing present, right? In GDHB, B's right part nothing is present means only B has left children. Okay, so the same thing we'll be writing here. B will be making, and B only has left children, which is GDH. Okay, same thing we'll do for EICF also. In EICF, it is in this sequence IEFC. So the end one is the one which is the root node. Okay, so here we'll be taking C as the root node. Okay, in post order it is LRN, so whichever the letter comes at the end, that is the root node, and the right part and the left part will be segregated after that, and C's left part will be in the left and C's right part will be in the right. But the right and left segregation will not happen in post order. You have to check this one. You have to check in order for the right and the left segregation. Okay, C's left part is having EI, so I'll be writing here EI, and C's right part is having F, so I'll be writing here F. So F is a single node. We have done with F. Now again we'll consider for GDH. GDH is present in this form GHD. Okay, that is left, right, and node. So at the end, whatever comes, that is the root node for the particular sequence. So in GDH, the D is the root node. Okay, D is the root node, and if D is the root node, we'll check where D comes. The left part of D is G, and the right part of D is H. So this is the sequence in order. Okay, so like this we'll write G and H. Okay, because of this L and R, the left part of D will be left tree and right part of D will be right tree. Now GDH is over, we are left with EI. EI, which comes last, I and E. So E is the N value, right? N is the node value, so E is connected directly here, and for the EI we'll be considering E here. E's left part will be left tree and E's right part will be right tree. In E's left part there is nothing, E's right part there is I. So I will be the right child of E. Okay, this is how you construct uh, a binary tree from the given in order or post order. They can give you any. Okay, they can give you post order or in order, or they can give you pre order or in order. Okay, but they will not give you post order and pre order. In that case it will be hard to segregate. Okay, in order will be there, along with that you can get post order or pre order. Okay, if in case it is pre order, you just have to shift this sequence from LR into NLR, and N is the starting node, so whichever is the starting node, that will be the root node, and you'll see the root node here also, and then you'll keep on segregating. Okay, so this is the final tree which you need to make an exam. Okay, moving on to the third super important question, which is define selection tree, construct a minimum winner for the tree For the runs of the game given below, each run consists of values of the players. Find out the first 5 winners. They have asked you to find out first 5 winners, and this is the tree which is given to us. Okay, so this is the format in which they will be giving. So we have to make a selection tree. Firstly, they have asked what is selection tree. Don't miss this one. Okay, you just you will be hurrying and writing the answer from here, but if you miss the definition, you will be missing some marks. Okay, so don't do that stupidness. You have to first write the definition. So what is the definition? Very simple. Selection tree is a complete binary tree. Okay, it is what? It is a complete binary tree. Every node has two children, where each node represents a match. Okay, in that, what each node represents, it's a match. Okay, match means it is a game between them. Okay, in a tournament tree with p players, there are p leaf nodes and p minus 1 internal nodes. Okay, just you have to write this simple definition. Tournament tree, selection tree, winner tree, all these things are same. You can write it like in a selection tree with p players, there are p leaf nodes and p minus 1 internal nodes. This is the definition into, right? And after that, the same table which is present here, this table you have to copy paste and make it in this format. Okay, just segregate it in different arrays here. Okay, after that, listen to me carefully what you have to do. In the exam, they can ask you minimum winner, minimum loser, maximum winner, or maximum loser also. Okay, so regardless of it is a winner or a loser, you just have to focus on the part minimum or maximum. Okay, so minimum means you have to consider a minimum element among these elements. Okay, so I'll tell you step by step what you have to do. You have to create circles about this one. Okay, what you'll create circles about this one. Okay, so let's create circles here, and in these circles what you have to fill, in these circles you have to fill these values. So 10 will be written here and you'll be scratching 10 from here, 9 will be written here and you'll be scratching from 9 from here. Same thing for the all other ones you have to do. Okay, so this is the first step where you will be initializing the now what you have to do, you have to compare between these two, means a match will happen again, and you have to find out an answer. Okay, so what answer you will find out for the notes which are being played match, what is the answer you will be finding out? The answer will be, since they have asked minimum winner, you have to find out the minimum value among these two. The minimum among 10 and 9 is 9, so you'll be writing 9 here. Minimum among 20 and 6 is 6. Minimum among 8 and 9 is 8. Minimum among 90 and 17 is 17. Okay, after you have done that, you will be repeating the same thing. Minimum among 9 and 6 is 6. Okay, and minimum among 8 and 17 is what? 8, right? And minimum among 6 and 8. What is the minimum among 6 and 8? Minimum of 6 and 8 is obviously it is 6, right? So we'll be taking it to the last level here and we'll be writing 6 here. So 6 is the minimum winner. Okay, so they have asked us to find out 5 winners here, right? First 5 winners. So for the first 5 winners, we'll be writing here as a winner list here. Okay, you'll be writing what? Winner list. Okay, and inside winner list you will be writing 6 first. Okay, then you'll be writing comma, and after this is done, the simple step what you have to do is erase all the places where the winner is present. So you'll be erasing this place and you'll be erasing this place, you'll be erasing this place and you'll be erasing this place from here. Okay, after you have done all of that, next step is whichever the empty space is there, there you will be pushing the element below this one. 6 was the winner, we removed 6, so the below this one is 15, so you'll be pushing 15 here. Now again a match will happen, 20 and 15 which is least, it is 15, 15 and 9 which is least, it is 9, 9 and 8 which is least, it is 8. So again 8 we have got here, so 8 is a winner. Next again the same step you will do, you'll remove 8 from here, here, here and here. Okay, after you have done that one, push what is the next element, which is the next element below 8, it is 15. So you'll be cutting it from here and we'll be writing here 15. Okay, and again 9 and 15 which is the least one, it is 9, right? So we'll be writing 9 here. 9 and 17 it is 9. 9 and 9 the least one is 9 only. Okay, so since least one is 9 only, we'll not do anything, we will write 9 as the third winner. Okay, and you'll be removing 9 from all the places where it is present. Okay, you'll be removing 9 from all the places where it is present. But since there is same number here, 9 and 9, we will be removing any of them. Okay, you can remove any of them, you can remove this 9 or you can remove this 9 from here. So in this case I'll be removing a 9 from here. Okay, so after removing the 9, the next element will be pushed from here. Okay, so what is the next element? It is 11. So 11 will be pushed from here, and the minimum one among 15 and 11 is 11, and another time it is 11 here, and minimum among 9 and 11 is 9. So again 9 has come here, so we'll be writing 9 here and we'll be removing it from the list. Okay, so we'll be removing 9 from here, here, here and here. Okay, after that we'll be taking the next element which is 20 here. Okay, we'll be writing 20 here, and this 11 was also taken, so I have scratched it. and 10 and 20, which is least 10, 10 and 15, which is least 10, 10 and 11, which is least 10, right? So we'll be writing 10 here, okay, and 10 will be taken as a winner. So we have got 5 winners. Okay, this is the first 5 winners list. Okay, this is the thing you need to write in the exam. Okay, moving on to the next super important question, which is define binary search tree. Construct a binary search tree for the following elements. Elements are given, and also we have to write a C function for inserting elements in a binary search tree. Now, what is the definition of binary search tree? Binary search tree is a tree, okay, that organizes nodes in a specific order. What it does, it organizes nodes in a specific order to facilitate searching, sorting, and retrieving data. Three things it does: searching, sorting, and retrieving data. That is called as binary search tree. Next, they have asked us to construct binary search tree, but before that, let's discuss the C function for inserting element in a binary search tree. So this is the code, very simple. You have to start from the struct node. This is the return type. Insert is the function name, and struct node star root in data. If root is null, create a new node and return it. That will be the final answer. If there is nothing is present, you will be just inserting that and making it as root. Now, if the data which we have got here, it is less than the root's data, we have to insert into the left part. So root's left part will be insert root left data. If it is in the right part means data is greater than root's data, it will be inserted in the right part. So we'll call the function insert with the root right and data. Okay, and the it will be returned and assigned to the right part here, right, root's right subtree. Okay, and then return root. If it is the same as the one which is passed here, in that case nothing will happen because we need not insert the same data if already that data exists. Okay, we just return the root. Okay, so this is the sequence given to us, and we can consider any of the nodes as root node. Okay, so in this case I'll consider the first node as the root node itself. So 100 I'll consider as root node. Now, very simple, you just have to tell me if it is left or right. 85 left, 45 left and left. Okay, 55 left, left but right. Okay, means you have to just consider at each point. If it is greater, put in right. If it is lesser, take it to left. 120, 120 is greater or lesser than 100. It is greater than 100, so I'll take it here. 120. 20, 20 is lesser than 100, lesser than 85, lesser than 45, so 20 will be taken here. 70, 70 is lesser than 100, lesser than 85, but greater than 45 and greater than 55, so 70 will be here. Next, 90, again the same path it will follow, but here it will be greater than 85, so 90 will be here. Okay, next 115, it is greater than 100 but less than 120, so 115 will be here. 65, lesser than 100, lesser than 85, greater than 45, and greater than 55 also, but lesser than 70, so 65 will be here. 130, greater than 100, greater than 120. 145, greater than 100, 120, and 130 also, so it will be here. 145. This is the binary search tree you have to write in the exam. Okay, BST for the given data. Okay, moving on to the last super important question of this module. Define a graph, show the adjacency matrix and adjacency list representation of the graph below. This is for 8 marks. Okay, very simple question, nothing much complicated here. First, define a graph. It is a non-linear data structure. Okay, it is a non-linear, means it is not in a single line, and there are no particular sequence here, so it is a non-linear data structure that consists of set of nodes and vertices. I mean a set of nodes or vertices and edges. Okay, means node or vertices is same, like 0, 1, 2, 3, and edges means that which connect them. Okay, so graph is a combination of nodes and edges. Okay, that is the definition you need to write. Second, show the adjacency matrix and adjacency list representation for the given graph. Two things you have to represent. First is adjacency matrix, and the second is adjacency list. Okay, so what is adjacency matrix? Firstly, what are the nodes given? 0, 1, 2, 3. So make that same order here, 0, 1, 2, 3, and the columns also 0, 1, 2, 3. Now, where connections are there? The self connections are not there. See, self loop are not there for 0, 1, 2, 3. So the self loop part, there will be a diagonal. Diagonals will be 0. Okay, 0 means there is no connection. 1 means there is connection. 0 with 0, there is a connection. No. 1 with 1, no connection. 2 with 2, no connection. 3 with 3, no connection. But 0 is connected with 1, 2, and 3. Similarly, 1 is connected with 0, 2, 3. 3 is connected with 1, 0, and 2. 2 is connected with 0, 1, 3. So in this case, all the nodes are connected with each other. So every place wherever a connection is there, 0 is connected with 1, yes. 0 is connected with 2, yes. 0 is connected with 3, yes. 1 is connected with 0, yes. 1 is connected with 2, yes. 1 is connected with 3, yes. So if it was a directional graph, okay, if it suppose that 0 with 2 it was like this, okay, then 0 to 2 I'll make a connection. 0 to 2 I'll write as 1, but 2 to 0 I'll write it as 0 only. 2 to 0 I'll write it here as 0. Why? Because it is a directional graph. Here our direction is specified, okay, but if the direction is not specified, that means the connection is from the both sides. 0 to 2 is connected, 2 to 0 is also connected, so we'll put 1 at all those places. That is how you make a adjacency matrix, okay. Next is you have to make the adjacency list, okay. For the adjacency list also very simple. What you have to do is write all the nodes which is present here, okay, write all the nodes which is present here, 0 1 2 3. Now 0 is connected with what? Any order you can take. It's connected with 1, it's connected with 2, it's connected with 3. So 0, you will make an arrow with 1, another connection here with 2, another connection here with 3, and the last one will be null. 1 is connected with 0 2 and 3. So for the same thing, 0 2 3, you'll make it like this. 2 is connected with 0 1 3, 3 is connected with 0 1 and 2. Okay, you'll make it like this. This is all you need to know from the module 4 of DSA. Please do like and subscribe, it helps me make more videos like this. And don't miss any of these questions. And thank you so much for watching. I'll see you in the next one.